All right. Welcome to the 2016 Practice AP Calculus AB exam, Section 2, Part B. This is the last section of the test. There are 4 questions here, number of problems, 4. We are going to do the first of 4 problems, which is free response question number 3. There will be another video for question 4, 5, and 6 after this. If you've been following me on our journey down the exam that is 2016, then welcome back. If not, and you just need the take a look at the work for free response question number 3, welcome. Give this video a like. You're going to like it. You know it. Follow me, because that's the only way you get notifications when I release the other videos that will follow. We don't get the calculator. Boo-hoo, that makes me sad. All right? And by the way, I've never said this before. Maybe I did. I've put up so many videos. If there's a test you want to see, if you want to see the 2010 AP Calculus AB exam, if you want to see the 2019, if you want to see the 1997, whatever, throw it in the comments. And if I could dig it up, I'll create videos for that one. Okay? Let's get started with free response question number 3. No calculators, don't worry, because it's the setup that's crucial. The algebra is typically easy for these ones. Oh, I love me some graphs. I love me some graphs. 3 states the function f is defined on the interval from -5 to c inclusive, where c is greater than 0. Okay, let me first of all explain. If c is greater than 0, obviously it's bigger than -5, but it's here, so it's a positive value on the x-axis. Okay, and f of c is 0. Okay, all that means is the coordinate is c on the x and 0 on the y. Okay, that's a coordinate. Train your brain. The graph of f, which consists of 3 line segments. Line segment 1, okay, line segment 2, because yes, those are 2 different line segments, and line segment 3, all right, and a quarter of a circle, which is right here. Okay, with the center of the circle at -3, 0, this would be the center, and the radius of 2. Okay, that is shown above. Find the average rate of change. I'm sorry, I'm clicking these things and not reading. Find the average, okay, it does say rate of change of f over the interval from -5 to 0. Average rate of change, that just means my change in y over my change in x. Okay, from this point, -5 to 0. From here to here. So all I'm going to do is, here's my first point at -5, 0. Here's my next point on the graph at 0, 2. All right, so we're just going to do change in y over change in x. Here we'll call this x1, y1, x2, and y2. All right, well, I told you the algebra is going to be easy. 2 minus 0, okay, over 0 minus -5. All right, 2 over 5. There you go. Bam, show the computations that led to your answer. Right there's the computations. The problems without the calculator can get complicated, but if they do, it's not because the algebra is difficult. All right? 3b. For x between -5 and c inclusive, let g be the function defined by g of x is the integration from -1 to x of f of t dt. Find the x coordinate of each point of inflection of the graph of g and justify your answer. Okay, couple of things here. First of all, this is g, and they want the points of inflection of g. Okay, points of inflection happens when my second derivative either goes from positive to negative or negative to positive. That can only happen when the second derivative is either 0 or undefined. Okay? I can only change signs around a second derivative that is equal to 0 or undefined. Okay? So first of all, let's figure out what the second derivative of g is. Okay. So first off, if g of x is the integration from -1x of f of t dt. All right? Let's take we need the first derivative first. Okay? We need to find the first derivative before we can find the second derivative. So let's take the derivative of both sides. Okay, so now I got g prime of x is, I love this. These kind of cancel, and my x just goes in for t. When I cancel the integration, the dummy variable goes away. So the first derivative of g is really f of x. It's our graph. The first derivative is the graph we have here. Okay, so now, now we don't only want the first derivative, we need the second derivative. Oh, I thought I hit the green one there. Second derivative. So again, I need to take the derivative of the first derivative. So now, okay, I'm going to do something here for a second. I had the first derivative, and this is what I had in green. That was what I have above before I wrote d over dx next to it. But when I take the derivative of the first derivative, I get it, boom, like an extra tick mark there. It's a second derivative. If I add one kind of little slash over here, I got to add one slash over there. So my second derivative of g ends up being the first derivative of f of x, or better known as, based on our graph, the slope of f of x. Isn't the derivative of f of x the same thing as the slope of f of x? It is, kids. It is. So this just helped us find the second derivative. We still need to find out where that second derivative is 0 or undefined. F. The slope or derivative of f is the second derivative of g. So let's figure out, where is the slope 0 or undefined? First of all, any corner, and it's undefined. Those are corners. You cannot take the derivatives or slopes at corners. Okay? So really, at x equals -3, at x equals -2, okay, and at x equals 0. Okay, so I'm going to put a number line. All right, let's do this just so we can see everything. Here's my number line. Here's the second derivative of g, which is also the slope of f. Okay, and here's our x values. At -3, it's undefined. Okay, at -2, it's undefined. And at 0, it's undefined. Okay, so let's see, again, if we look to the bottom left of my screen here, I want to see where my second derivative changes around those undefined values. Do they change from positive to negative or from negative to positive? If that's the case, it would be a point of inflection. So, this is a nice time for me to shine with my highlighters. Okay, right here, there's a corner, right here, and right here. Those are my 3 undefined values. Now let's take a look at what? What are we going to look at? The slope. Okay, this is a negative slope. Yep, that's green. My color coordination is bad, kids. This is downward. Okay, this is upward slope. This is a positive or upward slope. And this is a negative or decreasing function or a downward slope. So it's negative before my first. Okay, I'm reading this left to right. Okay, it's negative. Then in between -3 and -2, it's positive. In between -2 and 0, it still stays positive. And after 0, it's negative. So it switches here from negative to positive. So it switches here. This is one point of inflection. And it switches here from positive to negative. This is another point of inflection. This is not a point of inflection. Although it's undefined or zero, I don't change. It's positive. It hits undefined, but then it stays positive. Okay, so it's a sad face. Happy face continues to be happy, then sad. Changes here and here. So find the x coordinate, -3 and 0. So it happens at x equals -3 and 0. C. Find the value of C for which the average value of f over the interval from -5 to C is 1/2. Okay. Okay. Average value. Average value. Okay. Not to be confused with the average rate of change. The average rate of change is the average slope or average derivative when we have 2 points, change in y over change in x. We did that for part A. Average value means I take an integral from some lower bound A and upper bound B of some function, and then I multiply that times 1 over B minus A. That's where the average part comes. I got to divide by the difference of my upper and lower bounds. And dividing by the difference is like multiplying by 1 over that difference. So that's what we're going to do here. Except I don't have C. Not yet. But we're going to find that value where my average value equals 1/2. Okay? And we should be able to come up with a C. Okay? So first of all, lower bound, upper bound. Okay, so I'm going to integrate this from -5 to C times 1 over, okay, C minus a -5. All right. And, oh my goodness, how do I integrate this? Here's where the problem is. I don't have an equation. Remember, oh, I get to use the highlighters. Integration is the same thing as area under the curves. Okay, it's the area under the curves. So I'm going to use shapes, okay, to find the area under the curves. Now, here we go. Ready? First of all, we got this quarter circle with a radius of 2. Okay, I'll call this, this will be the green one right here. The area of my green quarter circle. Well, the area of a circle is pi r squared, but I want a quarter of that. So I'm going to multiply it times 1/4. My radius is 2, so it's 1/4 pi r squared. My r is 2. 2 squared is 4. 1/4 and 4 cancel. So really it's pi. The area of this is pi. But here's the thing. Anything that is below the x-axis is considered negative. Anything above the x-axis is considered positive. So that's really negative pi. All right? So this right here, we're going to start doing this. We have negative pi for my circle. All right? I'm going to combine that with, all right, we'll do blue. This little triangle right here. Okay, that's also below the x-axis, so it should be negative when we're all done. It looks like 1 is the little base, and it looks like this distance is 2. So that area of a triangle is 1/2 base times height. 1/2, 1 times 2. Okay, well, the 2 and the 1/2 cancel. It's just going to be 1. So this area is going to be negative because it's below the x-axis. So combine that with a -1. Plus, I'm going to break this up into 2 triangles because I like me some triangles. 2 and 2. Okay, so the area of that triangle, 1/2 base times height. 2 and 1/2 cancel. So that's 2. And that's a positive area. So plus 2 plus orange. We have this triangle here. Now, here is the case that we got here. I have this height is a 2, but this distance from here to here, whatever this is, it's C. Okay, if C was 3, then this would be 3. I don't know what it is, so I'm just going to leave it C. So the area of that triangle is 1/2 base times height, which is 1/2 times 2 times C. The 2 and 1/2 cancel, and I'm just left with C. This area is C plus C. What can I combine here? This is it. 2 and a negative 1. Okay, so when everything is all said and done, I have negative pi plus 1, because these two combine, plus C. That's this thing right here. I still need to multiply it. This is going to be 1 over C plus 5, okay, because when I subtract the negative, times 1 over C plus 5. And when I do that, it should all equal 1/2. My goodness. We're going to have to do some algebra here now. But you know what? That's fine. I'm good with it. I don't care. Let's get going. All right, let's, can I bring this down? Oh, it brings the whole thing down. Come on, shake, break. Oh, I'll just rewrite it. And this gives me a chance to get the calligraphy pen. I have 1 over C plus 5 times negative pi plus 1 plus C equals 1 over 2. Let's multiply this side by C plus 5. Multiply this times C plus 5. And then let's multiply this side times 2. So boom, boom, times 2. All right? So now, on the right side, I just have C plus 5. On the left side, I got to distribute this 2 to all three of these terms. So it's negative 2 pi plus 2 plus 2C. At this point, this is really just basic algebra. All right? I always say this to my calc students, that that's what calculus is. After the setup, it's always just comes down to basic algebra. Let's subtract 2 pi, subtract 2 pi. Boom. Subtract 2, subtract 2. Boom. And from the right side, I want to get rid of this C, because I want all my C's on the left and everything else on the right. 2C minus 1C is C equals, okay, 5 minus 2 is 3 minus 2 pi. All right? It was a lot of explanation, and if you know what you're doing, why do I feel like that should be plus 2 pi? It should be positive, positive, positive. Good. Glad I caught that. Sweet. Whew, would have been embarrassing if I would have got any points taken off on that one. Right, so it's 3 plus 2 pi, or you can write 2 pi plus 3. It's fine. In addition, your order does not matter. There you go. 3D is a lot less work than 3C was. But you've got to be able to wrap your head around what they're asking you to do, and then it becomes simple. 3D says, assume that C is greater than 3. All right? So whatever value this is, it has to be greater than 3. 4, 5, whatever. 3 is somewhere in between 0 and C. Okay? So if I put 3 here, it could be anywhere. Okay, but C has to be bigger than it, okay? Get rid of them. The function h is defined by h of x equals f of x over 2. Find h prime of 6 in terms of C. All right. That's right. All right, here we go. I'm going to go here. I'm going to grab my nice calligraphy pen, and let's end with this nice mint green. Okay. First of all, before I even plug a 6 into the derivative of h, let's find the derivative of h, the derivative of this thing here. So h of x is f of x over 2. All right? So h prime of x means I just take the derivative of this. I don't have an equation for f, so I know that the derivative of f is just f prime, okay? Chain rule. Always times the derivative of the inside. Okay? Quick little note here. If I have x over 2, don't do the quotient rule. That's like saying 1/2 x. The derivative of 1/2 x is just 1/2. Okay? I mean, you could do the quotient rule. You end up with the same thing, 1/2. Right? So here's my derivative. I want that at 6. Here. So now I want this at 6. So f prime of 6 over 2 times 1/2. Okay, let's simplify this a little bit more. In fact, let me bring this up here, okay, so we can see the graph as we do this. I have f prime of 6 over 2 times 1/2. That's like saying f prime of 3. In case you didn't know, guys, all right, 6 divided by 2 is 3. Now, remember when I said 3 has to be somewhere in between? Let's pick a spot. Here. I don't care if it's here, 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 whatever. Here. Now, what's important to know is, in the beginning of this whole free response question, it told us that this graph is made up of a quarter circle and 3 line segments. This is a line segment connecting 0 and C. If it's a line segment, that doesn't mean, well, that means no matter where I put 3, it doesn't matter where it is. The slope of this line segment will always be the same because it's a line. So look what they're asking me for here. The derivative of the derivative of f at 3 times 1/2. Okay? That's the slope of f at 3. The slope at f at 3 here is going to be the same as if 3 was here, or if 3 was here, okay, or if 3 was anywhere, because this is a line and the slope is the same. So how do I calculate it? Okay, well, I take this point, which is 0, 2, and this point, which is C, 0. And I just do change in y or change in x. All right. We'll call this y2, x2, and then x1 and y1. So we got 0 minus 2 all over C minus 0. So I have negative 2 over C. But Visca, I need a number. And no, you don't, because they want it in terms of C. You're going to have a C in your answer. Okay? The slope of 3 has to be negative 2 over C times our 1/2. What special little thing's going to happen? My 2's are going to cancel. So I end up with negative 1 over C. And that, my friends, is your answer. Goodness gracious. Y'all better like this video. That helps me. Follow me, because that helps you. So the next time I put up a video, you get a notification. And like I said before, I ain't going to start texting you guys when I put these videos up. I ain't going to do that, sorry. Just too many numbers. All 3 of you that follow me. I'm kidding. There's like, I don't know, 7. No, actually, for doing calculus, I got 100 people, some in Indonesia. I don't even know. They ask me questions. I got to put it in Google Translate because I can't answer it. It's crazy. But you, my friend, you have a question, you ask me, you like these videos, you follow me, so when I do free response question 4, you know when I put it up. And if there's a test, I said this at the beginning, that you want to see me do, I mean, let's call it what it is. Let's say your teacher assigns you questions from the 2007 test, and you're like, oh man, I wish Visca the teacher did the 2007 test. Put it in the comments. I'll do it. And you know what? I'm sure your teacher's not going to mind as long as you understand how it's done. Just don't copy the work. Understand how it's done. And then you can wow them. All right. Take it easy. I'll see you later. Bye-bye.